All right, everyone. So in this video, we're going to continue talking about significant figures. We'll talk about more of the rules for addition, subtraction, multiplication, and division. So to get started, guys, I wanted to add one more rule for significant figures, which is to remember that whenever you're looking at numbers which says that they're exact, or they're definite numbers, or they're counted numbers, then those numbers have infinite significant figures. Okay, what does that mean? So it means that let's say if I tell you that I counted that there are 32 students in this class, then there's no way to round off those numbers. You cannot have, no, so it's not possible that there were 32 and a half students in the class and that rounded off to 32, and then you only trust this number to two significant figures. That's not the case. This number has infinite sig figs. You can trust this number as much as you want. Okay, so for example, if you counted that there are $50 and you exactly counted that there are $50 counted, then that is again exact number, and you have infinite uh, significant figures. Okay, so to say, this answer for to answer this question, 32 students has how many significant figures? You can always rely on it that both of these numbers are sig figs, so these two are significant figures, but you can trust it to infinite numbers of significant figures. Okay. All right. Now let's talk about the addition, subtraction, and multiplication division rules. So first, let's talk about the multiplication and division. Remember them together because their rules are the same for multiplication division. And remember addition, subtraction together because their rules are the same. So when you add or subtract, their rules are the same. Okay, so multiplication and division. So let's take an example, guys. So if I take a number 20.6 and I multiply this number by 21, okay? So let's multiply these two numbers real quick, 20.6 times 21. The answer that I get is 432.6. The way I deal with the significant figures to round off the answer is this. So I have what I do is I look at the question. This question has how many significant figures? That's what I look at. So individually, this number has 1, 2, and 3 sig figs. I'll say here 3 SF. And this number here, 21, that's 2 sig figs, 2 SF. Okay. So the rule for multiplication division, what does it say? It says when you're multiplying and dividing two numbers, you go by the least number of sig figs, least number of sig figs. What does that mean? That 436.6 came from multiplication of these two numbers. These two numbers, they have 3 and 2 sig figs. The least number is 2. So your final answer, the final answer that you got, you can only trust 2 sig figs out of them. So if you can only trust 2 sig figs, you need to round it off to 2 sig figs. Okay. So right now, 436.6, that's 4 sig figs. I can only keep 2. What does that mean? I can only keep this number in the front, these two numbers in the front. I need to drop these numbers in the back. Okay. Now let's be very careful with this problem. Okay. So again, the problem is saying only 2 sig figs is what you can keep. When it comes to significant figures, you always start numbering numbers from the front. So you must keep these two numbers in the front, but you drop these numbers in the back. So guys, what is the rule for dropping numbers? When you drop numbers after the decimal, you can just ignore them. But when you drop numbers before the decimal, you cannot ignore them. You must replace those numbers by a 0. Okay, what does that mean? That means this 6 that I'm dropping, I can get rid of that 6 and forget about it. But this 6 that I'm dropping in front of the decimal, that must be replaced by a 0, okay? So I cannot have my answer just 43, okay? Because that changes the meaning of the number. So 436.6, if I ask you round it off, you cannot round it off to just 43 because you said that I have two sig figs. No, you cannot just keep two sig figs. I mean, you cannot just keep it to 43 because 436 does not round off to 43. Okay, and remember what I said? The number you drop before the decimal must be replaced by a 0. Okay, so the answer here will be 430. So guys, 430 has two sig figs, 4 and 3. 0 is not significant because this 0 is not sandwiched between two non-zero numbers. Why did I use that rule, guys? Because there's no decimal in this number. So no decimal means it's more difficult for 0 to be significant. It must be sandwiched between two non-zero numbers. This 0 is not sandwiched between two non-zero numbers. So this 0 is not significant. So I still have two sig figs. But the answer is 430, not 43. Okay, you have to keep that in mind. So 436.6 round up to 430. Think of this in your head. If you have $436.60 in your pocket, and I ask you, can you please round it off and tell me how much money you got? Will you say you got $43? No, then you're lying, right? It's nowhere close to what you actually have. 430, on the other hand, is pretty close to what you actually have. Okay, so I hope that is making sense. So when you're rounding off the numbers with regards to significant figures or significant figures in general, that still means, I mean, you're rounding off the numbers, but the numbers still keep their meaning. Okay. Okay. The idea, I mean, this what two things that you want to understand from this problem are these: that first of all, when you multiply two numbers, then in the final answer, you can keep the least number of significant figures. So in your question, if you have two numbers, like here we have 3 sig figs and 2 sig figs, you can only keep 2 sig figs in your answer. Okay. And secondly, the second thing you learn is how to round off the numbers when you are dropping numbers before or after the decimal. Okay. Right. By the way, guys, the number I got was 432.6. Okay. But still, the answer is still the same. Okay. All right. Okay. Now we'll do more problems, of course, but we want to discuss what are the rules for addition and subtraction. So let's say I had the same numbers, 20.6 and 21, and those are the two numbers that I was adding. Then what do we do? So guys, this 6 goes down, the decimal goes down, and then since you're adding them, 20 and 21, that becomes 41.6, right? So now how do we round addition subtraction? So when you're doing addition subtraction, the rules are not the same as multiplication division. In multiplication division, you go by the least number of significant figures, right? This is the rule we follow for multiplication division. But for addition subtraction, the rule is completely different. For addition subtraction, you must go by the least number of decimal places. This is very different. What does that mean? Let me give you a quick example. So let's say you were adding these numbers, 56.83 and then 2.05. Let's say you were adding these numbers, not 2.05, but 2.1, let's say. So you're adding these two numbers. So when I add these numbers, 3 gets down here, 8 plus 1 is 9, decimal goes down, 6 plus 2 is 8, and 5 goes down. So I get this answer. So the rule says for addition and subtraction, you go by the least number of decimal places. So you ask yourself, this first number has how many decimal places? this number, 56.83. First of all, what do we mean by decimal place? Decimal place are the number of digits. So the number of digits you got after the decimal. So for the first number, after decimal, I have 2 decimal places. Okay. For the second number, I only have 1 decimal place. So again, I have 2 DP, 2 decimal places for the first number, and 1 decimal place for the second number. So the idea is that you go by the least number of decimal places. Least number is 1. So in your answer, you can only keep the least number of decimal places, which means you can only keep 1 decimal place. So in the answer, 58.93, you can only keep 1 decimal place. You have to get rid of the second one. So guys, 58.93 just simply needs to be rounded off to 58.9. And that will be the answer. You don't even touch the 58, okay? Just look at the decimal places when you're adding, subtracting. If the number that you're dropping, since this number is 3, you just forget about it. And if this number was 5 or more, then you would be increasing the number you're keeping. You need to increase it by 1. Okay. All right. So now let's go back to the problem we were doing. 20.6 plus 21. 20.6 and 21, when you add them, you get 41.6. So now you need to follow the rule. The rule says go by the least number of decimal places. 20.6, how many decimal places does it have, guys? 20.6 has how many decimal places? It's just 1. So this guy has 1 DP. 21 has how many decimal places? There's no decimal. There's 0 decimal places. What does that mean? That in your answer, you go by the least number of decimal places, which is going to be 0 decimal places, which means you cannot keep the 6 anymore. You cannot have any decimal place in this answer. So your answer should just be 41, and that will be the final answer, guys. Okay, no decimal place, because the least number of decimal places is 0. You need to keep 0 decimal place. So the whole 0.6 needs to go. So the answer is just 41. Okay, all right. I hope that made sense here. So guys, this was the problem where we just learned individually multiplication, division, and then addition and subtraction. Okay, you will come across problems where you will be doing both of these in a combination, and you want to make sure you understand that. Okay, and let's do problems like that. So let's say you are given so let's say, guys, you're given this problem, okay, and you need to get the answer, and then bring it down. You need to give your answer with the correct significant figures. Okay. So when you're solving this, what you need to do is keep one thing in mind: is do one step at a time. Is to simplify the problem, and do not round off at each step. We will leave the rounding off to the final step, because you see, if you keep rounding off in each step, then you're losing information in each step. If there's a long problem and you see you're working in a lab, and there are too many there's too much data that you collected at different points, you start rounding off all of those numbers. At the very end, the answer you're going to get will be too big. So we don't want to do rounding off as we are solving the problem. We will do the rounding off at the very end when we get the final number. Okay. So the first thing is I just add the numbers in the front, 52.5 plus 2.386. So guys, the number that I get is 54.886. So guys, I'm not going to round off. I'm not going to round off any number. I'm just going to keep them as it is. And keep in mind, You see, in this step, I could have just put that into the calculator, 54.886 and divided by 29.5, but we don't want to do that. We don't want to lose any step. We want to keep track of each step. Okay, so then I would divide these two numbers, of course, in the next step. So when you do the simplification, do it one step at a time and do not round off. Just copy paste the whole thing. Don't be lazy, okay? All right. So here, let's now revisit this problem. So yes, we want to do the rounding off, but at the point when we will first solve the whole problem, okay? Then we go back and revisit each step. Okay, so the first step was what? The first step was to do the addition. Okay, for the addition, do you guys remember what was the rule for addition? Remember, the rule for addition and subtraction said you go by the least number of decimal places. Okay, so now I go back and visit the problem. 54.886 came from addition of these two numbers. I go and ask myself, how many decimal places do I have in these numbers? You see, I'm not looking at SIGFIX. Why not? Because this 54.886 came from addition, and addition does not follow SIGFIX. It follows decimal places. In the next step, this final number came from division. In that case, we will look at the SIGFIX and not the decimal places. So what step gave you that answer will decide if you look at SIGFIX or decimal places. Okay, so 54.886 came from addition of these two numbers. So you look for decimal places. This has one, so let me change the color. You have one decimal place. Here you have 3 decimal place. You can go by 1 decimal place. So guess what I do here? I'm not dropping the numbers. I'm not rounding off the numbers. What I'm just doing is I'm just labeling the numbers. That which numbers can I trust? Which numbers can I not trust? I can cross them off. So you can have your own way of tagging them. This is how I tag them. The one that I want to trust, I put a dash on them, and the one that I don't trust, I cross them off like that. Okay, so again, what I just did, let me recap that. I added these two numbers and I got 54.886. I go back and see this number has 1 decimal place. This one has 3. 1 decimal place is what we can trust. The remaining we cannot trust. But again, do you notice that we didn't do the division by ignoring that 8 and 6? This answer that I got has that 8 and 6 already included in the calculator, okay? So again, that was the point. We don't do the rounding off as we were solving the problem, but we get the answer, then we go back and revisit each step, okay? And at the final step, we will do the rounding off. Okay, so now let's see. So the addition is telling me I cannot trust this 8 and 6, but I can trust this first 8. Okay, that's good. What is next? The next step is that division gave me this number. Division says go by the least number of significant figures. Okay, now listen carefully. This number, 54.886, has how many significant figures? Keep in mind, it is the significant figures which you can trust, okay? So we are using that information we got earlier. This 8 and 6, we don't trust. This first 8 is the only number we trust here. So out of course, out of the decimals. So in 54.886, I have 3 significant figures, 5, 4, and 8. The 8 and 6 in the back, I cannot trust. So I have 3 SIGFIGs for the number on the top. And similarly, I have 3 SIGFIGs for the number in the bottom, because 29.5 didn't touch it. It's still the same, 3 SIGFIGs. So the least number of significant figures is 3. So it's 1.86. We keep those 3 SIGFIGs. We leave all those numbers out, and those numbers will be removed, and you will have 1.86 as the final answer with the 3 significant figures. Okay, so again, we did not do the rounding off. We kept all the numbers. We just back traced and saw which numbers we can trust and which ones we cannot. and then we just did the rounding off at the very final step. Okay. All right. I hope that makes sense. And that's it for this video.